this video, we will resolve a heat transfer problem by simulation using Ansys. So we're going to have the problem statement, the pre-analysis, then we'll do the geometry mesh and solution in Ansys, and then the verification. We have an aluminum pan whose thermal conductivity is 237 and has a flat bottom. They're giving us the diameter and the thickness. They're also telling us that the heat is transferred through the bottom of the pan at a rate of 8,000 watts. If the inner surface of the bottom of the pan is at 105 Celsius, determine the temperature of the outer surface of the bottom of the pan. Some assumptions we can make are steady state condition and no heat generation. From the problem statement, we can extract the important information such as the thermal conductivity, the diameter, and the heat flow. Since they tell us that it's a pan that has a flat bottom, we can assume that it's a perfect circle, so we can calculate the area that we're going to need later on. So the geometry we're gonna make in Ansys will be a circle with 0.5 meters of diameter and 0.004 meters of thickness. First of all, you have to install Ansys. I have the demo version. It's gonna be in the description. You can download it from there. So when you have Ansys installed, the first thing you have to do is type workbench and open Ansys. So the way Ansys works is that it has components. You can drag them to your project. In this case, we assume it's a steady state. So we will drag the steady state thermal to our project. So they're gonna be subcomponents. And the first one we're going to enter is the engineering data, so we can create our material. In this case, we type aluminum and we drag the isotropic thermal conductivity so we can put our value. In our case, it's 237. So we can close this and go to our project, geometry, so we can start designing our circle. Ansys uses space claim, and it takes a little bit of time to get it running. So after space claim is open, we're going to look at the bottom. There's a symbol with a pencil and a sketch. We're going to press that, and with that we can select our plane. As you can see, we're going to select the y-axis plane. To change units, we'll go to File, Space Claim Options. We select units, millimeters, we change it to meters, and we press OK. So to begin, we select circle, go to the center, click it. So the diameter is 0.15 meters, select enter. And now in the bottom, we select 3D mode, so we can turn it into a solid. So our thickness is going to be 0.004 meters. I press enter, and we have completed our domain. We exit space claim, and to do the mesh and the boundary condition, we'll go to model. So after our model open up, the first thing we're gonna do is we're gonna assign the material we created. We're gonna do that by going to geometry, solid, and the material is the default, and we'll put aluminum. So to generate the mesh, we'll right click mesh, generate. It will give us the default mesh. In this case, if you want to check the quality, we go in the bottom, quality. We'll use the common method orthogonal quality. We'll look at the minimum and maximum. So this mesh metric of orthogonal quality is a little complicated, but the important thing is we have to get closer to 1. In this case, our mesh is very good, so we can work with the default. And now to set up the boundary condition, we'll go to steady state, right click it, temperature. We'll select the inside face, and the temperature is 105 Celsius. So now for the other condition, we'll select steady state, right click, go to heat flow. We'll select the face outside. It's 8000 watts. As you can see, if we select steady state thermal with a left click, you can see all the condition we put to our domain. So now we can press solve. So after Ansys is done, we're gonna have all the green check marks. You're asking for the temperature, so we can go to the solution, right click, temperature, and we can say evaluate all results. And we can see the temperature in all of the body. You're asking for the outer surface. So we can look at the result on the left, the legend, or we can go to probe. We can probe the temperature to know its value. And now we can compare it with hand calculations. So in this case, the heat is transmitted by conduction. So we can apply Fourier's law. So we're gonna have the heat flow equals to the thermal conductivity multiplied by the area, and all this is gonna be multiplied by the temperature inside minus the temperature outside divided by the thickness. So when we solve for temperature inside, we will get 112.64 Celsius, and that's exactly the number we get in Ansys. So we can say we solved the problem.